2.7 is about piecewise functions, and we've talked about this in class. We're going to do a quick review of how these work. Your first example deals with what is the value of f of x given the values of x. And piece functions means your function will be one value if x is a certain value, and then it would look differently if that x is a different value. Here's the main example. This f of x is x plus 2 as long as x is less than 2, and it's 2x plus 1 if x is greater or equal to 2. The conditions are very important for anything we do, graphing or solving, because they're asking us, what is f of x when x is 0? Well, first of all, if x is 0, 0 is less than 2, so we're going to use this one. This becomes 0 plus 2. F of x equals 2. We use the first one because 0 satisfies the first condition. If I move to the second one, x is 4. 4 is greater than equal to negative 2, so now I'm going to use this one. 2 times 4, 8 plus 1, 9. So depending on what they tell you x is, you decide which one of the two piece functions you're going to use. You see where do they go in, or where is correctly applied, which in this case would be 0, would be this one. 4 is greater than 2 would be this one. Now, we're going to move on to graphing piece functions, right? Well, let's look at this. These are the same basic functions, but the key is always your condition. And right now we're doing with number 1, so, or x being 1. So I'm going to go ahead and do a dotted line on x equals 1, just so you know. It's a vertical line, we know this, and that's where it stops. And they're telling me if the values are less than or equal to 1, this is my function. So first of all, my y-intercept is 3 over 2. So if I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. 3 over 2, that's about 1 here, and then my slope will go 1 up and 2 over. This is tricky, so I can't go 2 over because I'm crossing the line. I'm going to go 1 down and 2 over. Right? Now I have the 2 dots. I'm going to go ahead and draw my line, and on this end, it's going to stop right there. That's where I end, right? That's where my function ends. It touches right there, and then it stops. And it would be an empty dot. Why? Because it's less than. My second function tells me my f of x is negative x plus 3 if x is greater or equal to 1. So let's go ahead and graph this one. First of all, I go to 3. That's my y-intercept. My slope is 1 over 1. It would be here and here. That's where I'm tempted to go. However, remember, I can't graph it this way because these are the numbers who are less than 1. So I'm going to go slope one more time, 1 and 1. I now have 2 dots. I can go ahead and draw my line. And this is greater than or equal to 1, so now it becomes a filled-in dot. They kind of go on top of each other, we said this in class, so you're going to end up with a filled-in dot just because they're overlap. So you have this line for this part, and I know it's going to have to end right here. Then my other line starts here and it goes down. The way I did it here is I just did the slope. My slope is negative 1 over 1, correct? So I go 1 down, 1 over. There's my second dot, and I can now graph the function. Let's look at this one. This is called a step function, and it's because it's going to be graphed as a step. Here's my graph, and I don't need the negative numbers at all, so I'm going to save some stuff. Here's what I know. First of all, my y is 1, my y is 2, my y is 3, my y is 4. I know it's going to be horizontal lines, right? And here's my values. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If my x values are in between 0 and 1, my value of that function, or y, will be 1. So I start at 0. This is my 0. And I end at 1. And it's going to be an empty dot. At 0 is a filled-in dot y. It's less than or equal to. But at 1 is an empty dot. Now, if my numbers are in between 1 and 2, my function is 2. It starts here and it ends here. It's a filled-in dot here because it's less than or equal to 1, so it can't touch 1. It's an empty dot at 2 because it's less than 2. If I'm moving between 2 and 3, it tells me that this line is now 3. Y is 3. Filled-in dot, empty dot, 3 to 4, filled-in dot, empty dot. So it's called a step function because you go step, 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 step. Really, you just want to know what is that value in between your x's. So in between here and here, I get 1. In between 1 and 2, my function is 2. In between 2 and 3, my function is 3. In between 3 and 4, my function is 4. Most important probably is your dots to know which ones are filled and which ones are not filled. Example 4 in your book is teaching you how to read or write by reading a piecewise function, right? And it's telling that it's giving us a graph and it says, can you write the rule for that function? The first thing you want to look is where does that function break? And if you look at it, it starts and it ends on 0. So I have either x is less than 0 or x is greater or equal to 0. How do I know where the equal goes? Well, if you look on the left of 0, on the top there you get an empty dot. So if it's less than 0, it's just less, it's not equal to because it's an empty dot. On the right side of the graph, when the light goes up, it's a filled in dot, which tells me that it's greater than or equal to 0. All I have to do now is read that graph. So I'm going to go with the first one. What happens when x is less than 0? Well, my y-intercept is 2, so my b is 2. And my slope is 2 over 2. If you look at it, it goes up 2 and over 2, which is 1. So my function is 1x plus 2, or you can leave the 1 out and just say x plus 2. If I move now to the second part, which is the right graph, I go my y-intercept is 0, 0, so my b is 0. My slope is again 2 over 2, which is 1, correct? So my f of x for this one is 1x, or I can write just x. I don't need to add the 0. So when you look at this, the first thing you want to do is see what is your condition. In this case was either x is less than 0 or x is greater than 0. And then we just learn how to read the graph, which we already did. We get our y-intercept out, we get our slope out, and then we write that as in y equals mx plus b. And that's how you write a function by looking at its graph. Okay, example 5 on page 116 talks about, again, reading a graph and writing the rule for that function. And as you look at that in your book, you're going to notice that you get to pay parking lot based on how long you're in there. Your first condition is t starts at 0 and it has to be greater than 0. How do I know? Because the empty dot is there and you can't touch half an hour or 0.5 of an hour. Why do I know this? Because it has a field in that right there. My second condition is when it starts at 6. So if it's greater than 6 hours, but less than, no, never mind. I'm reading the Y. It starts if you stay on the parking lot more than half an hour to up to 1 hour, right? And then the last one is if you stay more than 1 hour, but less or equal to 12 hours. It stops at number 12. So you read your x's here. In our case for the t, I read the y by mistake. So you get one charge if you stay under half hour, one charge if you stay in between half hour and 1 hour, and a different charge if you stay in between 1 and 12 hours. Most important part, make sure which one is the equal and which one does not have the equal. And now we look at this. So what happens if you stay under half an hour? You pay $3. If you stay in between half an hour and an hour, you pay $6. And if you stay more than that, you pay $8. We just wrote this piece function by reading the graph, right? They're also asking you for your domain. Domain stands for x, or in our case for t. Where does our time starts? It has to be greater than 0, because otherwise you're not considering parking. You have to stay at least 1 second there. And it can be up to 12 hours that you can park in that place. My range starts at your first value touch there. It's 3, right? Then 6, and then 8. You actually don't have an interval. You can either pay $3, $6, or $8. There's nothing in between. Your range is just the values or your y values, right? So as you read those graphs and trying to write the functions, always pay attention to your conditions. Our last example in the book, example 6, talks about what if you work at a place and you get paid one amount of money, and then for overtime you get paid 1.5, right? They say write and graph a piecewise function that gives you your weekly pay P in terms of the number of hours you work. So if you just work 40-hour week, you get $7 an hour. So this is just 7 times how many hours you work, and that would be if you work in between 0 and 7 and 40 hours a week, right? It's just that's what you get. You get $7 an hour. But if you work overtime, you get paid overtime. Let's figure out how that looks like. Well, if in order to be paid overtime, you first would have to work 40 hours or $7 per hour, and then you're going to be paid 1.5 times that 7 and times the hours you worked over the 40. So it's going to be, in this case, we're going to have how many hours you worked minus the 40 that you were paid for right here. When we open all of these parentheses, we get 280 plus, I do not know what this is, 1.5 times 7, 10.5, I think. I think it's minus plus 10.5. And then minus 60. So I believe this comes to 10.5 hours, 280 minus 60 plus 280. Oh, I did this wrong. I'm so sorry. It's 10.5 times negative 40 times. Let me do this. 10.5 times negative 40. This is minus 420. So this becomes that minus 140. 280 minus 220 is negative 140. So my second line is 10.5 hours minus 140. And that's when your hours are over 40 hours. You get two different kind of pays. You get $7 an hour if you just work 40 hours. You get this much money if you work overtime, right? And then they're saying graph it. If we're going to go ahead and graph it, the graph is in the book. I'm not going to graph it again. But the way you would look at it is, just to remind you, this is a real life. Your dotted line was going to be over 40, right? You have one way to go, kind of like this, if you work like that, right? And then you get a lot more pay. So it's going to be a little bit steeper if you go like this. Now your point B, it says, how much will you get paid if you work 45 hours a week? Which one of the two you're going to use? 45 is greater than 40. You're going to work over here. So if you put that in your calculator, you get 10.5 times 45 minus 140. You would be paid $332.50. This is how we do that problem. Happy homework with your piece function.